Yeah, let's start over. So yeah, I'm going to present DAOS core features we worked on this year. And yeah, some of them will be in 2.0 and some of them will be in future releases. Okay, yeah, good. So Erasure Code. Erasure Code is the biggest feature we worked on this year, and it is the second data protection method supported by DAOS. And replication is the first one. So EC is more space and bandwidth efficient than replication, but it's more expensive because it requires a lot of computation. Specifically, because DAOS client is is a library linked with the application and compute node, and compute node has way more compute resource than DAOS server. So data encoding of DAOS is handled by client on write, which means that the client should compute the parity and create bulk descriptor for both data and parity, then send RPC request to the leader server of the parity group. And yeah, if the write is not aligned with the EC stripe size, because DAOS is a multi-version object store, which means that data model of DAOS is versioned. So instead of doing read, encode, write, which is very efficient, right? Because it requires the distributed locking, they'll simply replicate the partial write data and store them in parity object shard. And after a certain amount of time, if the application keep writes and compose a full stripe eventually, the server can compute parity based on all the replicated data. And if application overrides a full stripe, then the aggregation process is more complex and it requires data transfer between servers, and we won't have time to introduce the detailed protocol here. Degraded mode is the first approach that EC provides availability of data on storage failure. In this mode, the client has to fetch the full data stripe and reconstruct the missing piece of data on read. So it is more heavyweight comparing with the degraded mode of replication, because obviously it has to read multiple pieces of data to reconstruct one piece of data. And the rebuild system is the second component to provide data availability of EC. It is a background service which can reconstruct the missing data or parity in the background. And the rebuild of EC is similar with replication, but there will be more data movement for EC rebuild. And yeah, if we use this diagram as example, we lost one piece of data, one piece of the data shard. We have to read two data shards and one parity shard to reconstruct the missing piece. But after rebuild application and the DAOS client can application and DAOS client can exit from the degraded mode and recover to the normal performance of the system. And user actually has two ways to use EC in DAOS. The first way is use the low-level API and specify the EC object class for object during I/O. On the other hand, if user is using DFS, then based on the redundancy requirement of user and the size of storage pool, I mean number of engines in the pool, DFS will automatically choose EC for file. In addition, user can also specify cell size of EC at pool or container level. Using small cell size can reduce the chance of partial writes and reduce the workload of EC aggregation, but it will increase the overall metadata consumption in PMAM, and also impact the RDMA performance for some network provider. And yeah, the feature will be available in release 2.0. Distributed transaction of DAOS is using a variant of two-phase commit. We already use this protocol to support atomicity of replicated writes and the EC write. Now we also use it to support transaction API of DAOS. For example, user can start a transaction and submit a bunch of IO operations in this transaction, then commit. And if the commit failed, all the changes will be rolled back. And if the commit succeeded, all the updates will be applied. Because DAOS does not monitor a lively status of client, so if a client process crashed before commit transaction, this transaction may dangle for undeterministic amount of time and generate a lot of false conflicts on server. So DAOS uses a different way to support transaction API. It only submit read request and cache all writes within a transaction on the client, and only submit these writes as a component RPC to the server on commit call of the API. So the selected server will be the actual two-phase commit coordinator. It will run the full two-phase commit protocol for all the component operations. And because DAOS does monitor status of servers, so if the leader server failed for some reason, all the server will know, and they can run extra protocols to either commit or abort two-phase commit transaction instead of leaving an unknown status dangling transaction. So, and because DAOS server will log all the active and committed transactions, so DAOS actually uses this transaction log to do the resend check. So if a client got a timeout on RPC and they resend the RPC, DAOS server will not re-execute the same transaction for multiple times because the transaction ID has been logged on the server. And of course, the transaction log won't grow forever, right? We have a background service to remove those committed transactions if the total number of log entries exceed a threshold. And this feature is already implemented and it's used by DFS API like OnLink, but it still requires more tests while integrating with the data recovery system. So user transaction API will be officially available in 2.4 release. Checksum. DAOS already has checksum framework for a while, but it was not well integrated with other components like rebuild and the aggregation services. This year, we integrated the checksum with this component. For example, if checksum is enabled, as you can see from this diagram, DAOS aggregation service will recompute new checksum while merging small extent to large write, and the DAOS rebuild service will also verify checksum while reconstructing data. In addition, while checksum is enabled, just to report checksum error to user or application is not good enough, because if user has already chosen data protection for the dataset, either EC or replication, the data should still be available even there is a checksum error from one device or engine, right? So we also integrated checksum with the client stack. If the client stack detects a checksum error on a read, it will switch to degraded mode for this particular IO and read from either another replica or do EC degraded mode read, which requires to read from multiple servers. And checksum scrubbing is a feature which is still in development. It will be available in Q4 release, and it's a background service which will scan all the data and verify the checksum. And if a checksum error is detected, it will submit a REST event, and the admin can decide to evict or replace the bad device from the system if there are too many errors detected on the same particular device. We also worked on the rest part of the IO stack. For example, we added a VMD device support to DAOS. VMD here is a Intel volume management device. So DAOS can show SSD status on LED lights, and admin can remotely control these lights and show which SSD, for example, is faulty or which SSD is in rebuild, or just to simply show the light to locate an SSD. And we also changed the object ID format, and the main goal is encoding the number of object shards in the OID. Originally, DAOS provide a few hundred predefined object classes. Each of them has a certain number of shards. So user can only select from these predefined classes. If the object class does not match with the storage system size, for example, the storage system has like 20 engines, but DAOS only has only predefined 16 and 24 shards, then user cannot achieve full bandwidth of the system. With this change, for example, DFS can find out the number of engines in the system while opening a container, right, and encode the actual number of shards in OID based on the performance requirement while creating a file object. And so user can always achieve the required performance from the file object. We also implemented the object table in DAOS. It's not maintained during regular I/O, the table. Instead, it is created for a snapshot on demand. So the user can enumerate all the OIDs of a snapshot from the enumeration API. And this feature is required for example, for data mover and probably the future catastrophic recovery. We also did a lot of work to improve performance of DAOS. Here we just list a few of them. The first one is pre-register all the DMA buffer for RDMA. DAOS is using SBDK DMA buffer for RDMA. If we always register RDMA MR on demand, then it can badly hurt performance if applications submit a lot of small or medium-sized I/O, like 8K, 16K, or 64K. Because MR registration is more expensive than RDMA itself. Now DAOS server will always pre-allocate DMA buffer and register MRs for those buffers after the allocation. So there is no MR registration for each IO anymore. We also set a threshold for the DMA buffer size consumed by the rebuild system. The background rebuild system will not consume all the buffer for data reconstruction, and the I/O service can still handle regular I/O from client when rebuild is running. Aggregation service, it can migrate it from SCM to SSD and merge data extent on SSD to reduce fragmentation. But similar as rebuild, it consumes CPU cycles and the storage bandwidth. So we added some policy to the I/O scheduler of DAOS server and make sure that aggregation is a low priority service when the pool still has plenty of space, and prioritize it when the pool is under space pressure. DAOS has no version compatibility before 2.0, which means if you install DAOS 1.0, 1.2, and upgrade to 2.0, then the new engine cannot boot from the old storage. For release 2.0, we have already stabilized our durable formatting in persistent memory and the RPC format as well. So, the data stored in 2.0 can be loaded for future version of DAOS. SMD is a server metadata database used by DAOS engine to store local storage metadata. Originally, it has its own data format, which is different with WAS. And in 2.0 release, we changed the SMD and implementation and just use the WAS as the, which can be abstracted as a KV store, right, to store SMD data. So we can, in the future, we can use the same tool to do the consistency check, and it will be easier for us to support catastrophic recovery in the future. We also did a lot of work to improve usability of DAOS. First of all, we added the redundancy factor to container, as I introduced earlier, if DAOS does, because DAOS does not maintain object table during regular I/O. It means that when failure happens, user might have no idea about if there is a data loss or not. And redundancy factor is a new property we added for DAOS container. It indicates the maximum concurrent failures this container can tolerate. For example, if user set the redundancy factor to 2, then DFS will always choose three-way replication or ECK+2 for data protection. User can still use the container when there is 1 or 2 failures, because it's guaranteed that all objects will be available. But if for example, if 3 engines failed at the same time, then this container is at risk of data loss. So user cannot proceed I/O or use the container. User has to either ask the main to bring back those failed engines or manually enable the container again if user can take the risk of data loss. And in 2.0, we added a event framework for communicating significant information of DAOS system. This event includes the rebuild event and SBDK errors, checksum scrubbing errors, swing event. user can find those events from the syslog. And DAOS server are now linked against the telemetry library, so it can collect a server-side metrics for performance testing as well as system monitoring. And DAOS use Prometheus, which is an open source toolkit for time series data storage, and Grafana for visualization of the metrics. And the main metrics collected by DAOS server includes the number of, for example, number of queued IO, and IO handling time, number of active IOs, number of regular IOs, and recent IOs, and number of version extender allocations, and number of free blocks. Yeah, all those kind of information. And we did some improvement to DAOS perf and object control and object consistent checker as well. Originally, both DAOS pool and container are identified by UUID. This is simple because, but not easy for user, right? Because it's just very hard for user to remember UUID. So in 2.0 release, DAOS require user to associate a label with the pool container operations, and also provide API and a tool to show this label and even manage the pool by label. Ideally, a user of DAOS should be able to install and run without having to manually configure the necessary hardware devices, I mean network or storage device. And to make this be possible, and DAOS provide a tool to discover and provision and select the hardware device necessary to give DAOS optimal performance. Specifically, user can just need to run a DMG config generate command with some hardware hints. If the required hardware is detected on all the nodes listed in the command as the command parameters, DMG will display the generated config on STD out. So admin can review it and save it as file, modify it as necessary, and then push it out to the servers. Originally, pool creation of DAOS require user to provide per engine storage size, which is confusing and easy to make mistakes. Now we changed it so pool creation accept the overall size of persistent memory and NVMe of the whole storage pool. And for tools like DMG DAOS server, we changed those always required arguments to positional, for example, container label. So user have to follow the special syntax of those tools and have less chance to make mistake while using these tools. Okay, yeah, I only have 20 minutes, so I cannot cover everything, but that's all the content